Okay, so we are going to learn how to solve some equations with radicals in them. They are a lot like equations with absolute values. So when we learned about equations with absolute values, we learned that you had to isolate the absolute value first. That's going to be true for equations with radicals. The radical itself, whatever kind of root you have, has to be alone. Now, to get the variable out from underneath this radical, you need to reverse the radical. So a square root is the opposite of a square. So if you're going to square one side, you need to square the other, which means that your square and the square root itself cancels, and so what you're left with is what is underneath the radical. So you're left with 2x minus 1. And then we're going to square the 3. And once we do this, you could solve. And we get x equals 5. Now one thing that you have to be careful about is that when you're checking your work, is that the x value that you get does not make this area under your square root negative. So it is necessary to check, because sometimes you will get a no solution when you're solving one of these problems. So I'm going to put this back in my original problem before I squared it. And I'm asking myself, is the square root of 2 times 5 minus 1 equal to 3? And 2 times 5 minus 1 is 9, and the square root of 9 is 3. So that is how we solve this problem. Now this problem, the x is not isolated. You want to solve for the variable. Well, you want to solve for the variable, but you need to get the radical alone first, which means we need to get rid of this 1, and that 2 also needs to be moved. So when you're getting rid of something, really what you're doing is adding it to both sides. And my variable is still not isolated. It still has a 2 multiplied by it, so we're going to divide both sides by 2. And then that leaves me with the cube root of x equals 2. So then to solve for the x, we haven't solved for the x, we need to get, this x needs to be out from under the radical. And since that radical is a cube root, then we are going to cube both sides. The cube and the cube root basically serve as reciprocals. So then I would have x equals 8. And you do need to check. So always check in your original problem. And I put a question mark because I'm wondering, is that really equal to 3? And the cube root of 8 is 2. And I have 4 minus 1, and that is equal to 3. So I have found the correct answer. Now this problem has an extra x on the outside, and my radical here is not isolated. It has a 3 subtracted. So I need to isolate my square root. I'm going to add 3 to both sides. So I've got the square root of 8x plus 24, and that is equal to x plus 3. And I need to reverse my square root, and I'm going to reverse my square root by squaring both sides. Now, you cannot distribute this 2 here and here. You can't say x squared plus 9. That's not squaring the entire side. That's squaring by terms, and you're not going to do that. So what this is saying is that you have an x plus 3 and an x plus 3. So you're going to need to FOIL that. So on your left side, since your square has canceled your square root, you're just left with 8x plus 24. On your right side, after you distribute and collect like terms, and you'll have x squared plus 6x plus 9. Now, whenever you have a square or any bigger exponent, you're going to need to set this equal to 0 to solve for your variable. Now, I'm going to subtract 8x, and that gives me negative 2x, and I'm going to subtract 24, and that gives me negative 15. And I'm going to factor this. Factors of negative 15 that add to make negative 3 or negative 5 and positive 3. So my x is either going to be 5 or negative 3. Now, we do need to check these. So you're going to put the 5 back up here, so that gives you 40 plus 24, that's 64. Square root of 64 is 8, and 8 minus 3 is 5. And my x was 5, so that checks. And then I'm going to try out my negative 3. So I've got 8 times negative 3 plus 24. That's 0. That goes away. So that leaves me with negative 3 equals negative 3. So both of these did check.